Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about problem solving on decimal to any radix conversion. So what are the possibilities are there to convert from decimal to any radix conversion? Suppose I am taking here one decimal, convert to octal is possible, and binary is possible, and hexadecimal is possible. So there are three possibilities are there. Three possibilities to convert from decimal to any radix. Decimal to any radix. So suppose I am taking from some decimal number anything, convert to binary. Okay, it is one conversion, and decimal to octal, decimal to hexadecimal. So it is one possibility, and it is another possibility, and it is another possibility. So there are three possibilities. There are three possibilities are there to convert from decimal to binary, decimal to octal, and decimal to hexadecimal. So suppose I am taking example here, some 548. So it is a range of beyond the decimal values only. What are the decimal values? 0 to 9 we have to take. So it is a beyond the values of 0 to 9 only. So we have to convert to binary is one possibility, convert to octal, and convert to hexadecimal. So these are the three possibilities are there to convert from decimal to any radix. So first one we have to go for decimal to binary conversion. A decimal to binary number have base 10 and the binary number has base 2. Suppose I want to convert to decimal to binary. So what is the first rule means? What is a radix or base? It is called radix. It is called radix or base. So here it is a radix and base. So first of all, what is the rule means? At the left, what is the decimal value? Is it 10 is there or not? We have to check. First one is a base. Yes, base 10 is there. So these base 10 convert to the base 2 value. Okay, and the decimal to binary conversion. Here decimal value is there to convert to the binary. So the base 10 converting to the base 2. That means decimal to binary conversion. So all the decimal numbers have their equivalent binary numbers. These binary numbers are majority used in computer applications where it is used in programming or coding purposes. This is because of computer understanding the language of binary digits 0 and 1. So what are the advantages are there if you are converting from binary? So first, binary means computer understanding language. Computer understanding language. So binary means in the form of zeros and ones. Okay, and other one for coding and execution purpose we are using. So computer understanding language is a low level language. So low level language is also called binary language or binary code. So all the decimal numbers have their equivalent binary numbers, and these binary numbers are majority used in computer applications. So what are the binary numbers are there? Suppose my input is decimal, I want to convert to the binary conversion. So why I am converting to the binary means binary conversions are nothing but it is used in computer applications and used for programming or coding purposes. This is because of computer understanding the language of binary digits 0 and 1. So what are the techniques for decimal to binary? So divide by base and keep track of the remainder. First remainder is bit 0 LSB and second remainder is bit 1. So suppose I am taking 548 example. So base 10 convert to binary. So we are taking from it is the LSB. It is called MSB. So at the rightmost value it is a LSB, leftmost value it is a MSB. So it is called least significant bit, and MSB is called most significant bit. Least significant bit and most significant bit. So when we are going for the decimal to binary, so what is the first rule means divide the base value. So what is I want to convert? I want to convert to the binary. So we have to divide this value with this. So what is here? 2. Otherwise, if I am converting to the octal, if I want to convert to the hexa, so what we are converting, what is the conversion value? This conversion radix value is dividing with this binary decimal value. So divide the base, keep track of the remainder. First remainder of bit 0, that is the least significant bit we can understand, and the second remainder is what is a bit 1, etc. So we are taking from decimal to binary. So what are the steps are needed? What are the steps are there to convert from decimal to binary? We can convert the given decimal to binary using different methods such as formula, division method, and so on. In the section, we will learn how to convert decimal numbers to binary in the division method in the next, and to convert the decimal to binary numbers with the steps given below. Step 1, divide the given decimal number by 2 where it is gives the result along with the remainder, and if the given decimal number is even, then the result will be whole, it gives remainder 0. Okay, so it is even value or odd value we have to find out. First step 1, the given decimal value, what is the value here? This value we are dividing with 2. Here 548. So we have to divide with what is the value here? Converting to the binary. As I want to convert to binary, you can divide this one, and it gives the result along with the remainder. So what are the remainder? What are the values we are getting the result? And if the given decimal number is even, the number is even, then the result will be whole. It gives the remainder 0. If it is even, we are getting the result is 0. Why? Because it is the even number. If the value also even, then we are getting the 0 is the remainder. So step 3, if the given decimal number is odd, then the result is not divided properly and it gives the remainder 1. Why? Because we are dividing with 2. So 2 is the even number. When it is an odd number, example 547, is it odd number? Yes. Then the remainder is 1. By placing all the remainders in order to such a way, the least significant bit at the topmost of the most significant bit at the bottom, the required the bottom numbers will be obtained. We are getting the values from last. How can we dividing from bottom to top? Bottom to top. So bottom means it is a MSB value we are getting. At the top value we are getting LSB, least significant bit. So what are the first step means? Divide the decimal by 2 and give the result along with the remainder. And step 2, given decimal number is even, then the result will be remainder is 0. If the value is odd, then the remainder is 1. And what are the result values we are getting at the remainder? We are taking from bottom to top values. At the bottom most value is the most significant bit, and the top value I am taking as a LSB. So here, example I am taking, convert the given decimal number 294 into binary number. So convert the given decimal number 294 into binary number. 294, what is exactly here? 294 base 10. Why? Because decimal number, here the mentioned the decimal number 294. That means 294, what is the radix here? 10. And converting to the binary number. Converting to the binary number means in the form of 0 or 1 values only. So here I am taking 294 divided with 2. Why? Because what is the radix? What is the output radix? What you want to converting? So I want to convert to binary. So binary means 2. I want to convert to octal. Okay, you have to take 8. I want to convert to hexa. You have to take the divided with 16. So now I want to convert to binary. So 294, the decimal value 294 and dividing with 2. So what is the result now? 147. So if it is even number, then remainder is 0. And what is the binary value now? The LSB value is a least significant value is a 0. And 147. Now the result is 147. Is it even or odd? Yes, it is a odd number. Then the remainder is 1. Then 73 is a odd number. 73 by 2, 1. 36 I got. 36 by 2, 18. So 0. 18 by 2, 9. 0. 9 divided with 2, 4. Even it is odd number? Yes, 1 remainder. And 4 with 2, 0. 2 by 2. And 2 divided with 1, 0 and 1. So what is our value now? 1 double 0, 1 double 0, 110. So here it is the MSB value and it is the LSB value. So least significant bit is a 0 and most significant bit is a bottom value is a MSB. Most significant and the top value is a LSB, least significant value. So what are the binary values now? 1 double 0, 1 double 0, 1 double 0, double 1. It is a LSB, least significant bit. So we got 1 double 0, 1 double 0, double 1 0. So I am taking one example too. Convert 125 base 10 with binary number. Okay. So what is our question actually? Decimal to any radix. So here my question is decimal to any radix. Decimal to any radix means decimal value is converting to the binary. So 125 I am dividing with 2. So 2 6 ja 12, 2 2 ja 4, 1 and 2 3 ja and 2 1 ja 0, 2 15 ja 30. Remainder is 1. 2 7 ja 14. Remainder is 1. 2 3 ja 6. Remainder is 1. 2 1 ja 2. Remainder is 1. 2 0 ja 1. So already we discussed it. It is the MSB value and it is a LSB value. We have to take the value from bottom to top. So bottom to top means 1 1 1 1 1. 5 ones are there and 0 1. So it is a base 2. So first conversion is from decimal to radix is completed. So I am taking another example. 2 4 ja 2 3 ja 0, 2 2 ja 2 1 ja and 220, 2 5 ja 0, 2 2 ja 4, 2 1 ja 2, 2 0 ja 1. So what is the now? It is the MSB value and it is the LSB value. So bottom to top you have to take the values 1 0 1 0 double 1 0 base 2. So it is the LSB and it is the MSB. So we are converting from decimal to binary is completed. So one conversion is completed. Next, convert from decimal to octal with steps. First, what is the first step? First we have to take the decimal number with the radix 10 and the given decimal number is less than 8. Then the octal number is the same value. First, what is the range of this decimal value and what is the range of octal? We have to find out. And if the decimal number is greater than 7, then dividing with number 8. And note that we can get the after division, we will get the quotient. What is the remainder value? And the remainder's reverse order, bottom to top. The resultant is the equivalent octal number to given the decimal remainder. So I want to convert to decimal to octal. So what is the process? Same as this, we are dividing with the decimal value. So suppose decimal value is 543. So we have to divide with 8. So what is the remainders? We will get, and bottom to top we have to take the values. Okay, we have to take one example. I am taking here example 3. Convert decimal number 1 2 3 4 into octal number. So here now 1 2 3 4 decimal number they mentioned. So radix equal to 10. Convert to the octal number. So what is the result value? We have to take the with radix 8. So 1 2 3 4 dividing with 8. So 8 into 154. What is the remainder is 2, carries 2. So 8 19. So carries 2 remainder, and 8 2 ja 16, carries 3, 8 zeros are 2. So 2 3 double 2, 2 3 double 2. MSB and it is a LSB. Most significant bit, least significant bit. So what is the formula? Decimal to any radix. What is the formula means? We can divide the value. Decimal to any radix. We can divide the value which with resultant radix and with decimal value. So decimal value divided with radix value. So what is the decimal value here? That decimal value divided with radix value. Previously we discussed 1, 2, 3, 4. So it is a decimal value. Yes, in the question they given. I want to convert to octal. So what it will be? It is a decimal to hexa, decimal to binary, or decimal to octal. Anything, any decimal converter radix, we have to divide with output radix. Okay. So 1, 2, 3, 4 is there. So you can take outside is not only binary. If I have hexa, if I have binary, you can divide with anything, 8 or 16 or 2, anything. You have to divide with that one. So convert 1792 into octal number. One example I am taking, 1792 base 10 convert to octal. Okay, so 1792 I am taking, dividing with 8. So quotient is 224 and remainder is 0. So what is octal number? Now 0. So again, this quotient value 224 dividing with 8, quotient is 28, remainder equal to 0. Octal is 0. And again 28 is remaining. This 28 dividing with 8, 8 3 is 24. So remainder equal to 4. And here 3 quotient is there. 3 divided with 8, 0 and 3. So what is the value now? I am taking answer. Octal number is 3400, like this. Okay, 3400 base 8. So what is the decimal value? 1792 base 10. 1792 base 10 converting to the octal. So decimal to octal conversion is completed. Next another value, convert 127 base 10 to octal. We are dividing with 127 by 8. So 127 dividing with 8. So what is the quotient value? 15 and remainder equal to 7. And again we are dividing with 8. 8 to the 16, but here 15 is there. 8 1 is 8. So what is the remaining value? 8 1 is 8 means remaining is 7. Next 8 0 is 1. So what is the answer now? 177 base 8. So 177 base 8. So what is the, these are called quotients. Quotient, and these are the called remainder, and it is called quotient. So what is the quotient value and what is the remainder value? So we have to take the remainder value from bottom to top, that is from MSB to LSB. So example, convert 52 base 10 to octal. 52 base 10 to octal. Okay. First, what is 8 6 48. So how much now? 4. 8 0 6. So what is now? 64 base 8. So 64 base 8. So these are the remainder. It is a quotient. So convert 52 base 10 to octal. Anything. Now decimal to hexadecimal conversion with steps. First, divide the decimal number by 16. considering the number as integer. Okay, we have to take the integer and keep the remainder aside, and again divide the quotient to 16, repeating till get the quotient value is 0, and now take the values of the remainder at the left in the reverse order to get the hexadecimal numbers. So what is the decimal number? You have to convert to the hexadecimal. These hexadecimal you have to divide with the decimal value, and what is the quotient values are there up to 0. What is the quotient value is there up to 0? You have to do the work. So up to 0. If you got the 0, then you can stop that one. And here one example of the decimal to hexa table. Here decimal numbers are from 0, 1, 2, 3, 4, 5, 6 I am taking, but here actually decimal numbers are from 0 to 9 only. So in the equivalent hexadecimal value 0, 1, 2, 3, 4, 5, 6, then when the decimal number is 10 means 1 I am taking as 1 and 0. So in the hexadecimal numbers after 9 I have to take A, B, C, D, E, F. Why? Because hexadecimal values are 16 values. That means from 0 to 15. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, I have to take A, B, C, D, E, F. So 9, 10, 11, 12, 13, 14, 15. So hexadecimal values are 0 to 15. That means 0 to F. What are the decimal values from 0 to 9? Again, it is repeating from 10 to 15. So here I am taking one example. Convert 960 base 10 into hexadecimal. They given 960 value, that is in the range of hexadecimal decimal only. We have to convert to the hexa. So 960 16 okay, and here 16 6 are 96 and it is 0. What is the remainder? 0, and 16 with 3, 16 3 are 48, 12, and 16 zeros are 3. So what is our value now? 3, 12, 0. But here already we know that what is the 12 value here? The 12 value here is a C value. So 3, 12 value is C and 0. 3C 0 base 16. The output is 3C 0. Why? Because after 9 we have to take the values are in the range of A, B, C, D, E, F only. So like this we are taking. Convert 1228 base 10 into the hexadecimal. 1228 into dividing with 16. 1228 base 10 convert to hexa. So 1228 converting to the hexa means quotient 1228 dividing with 16, quotient is 76 and remainder is 12, and the hexa value is C. 76 base 16, it is the 4 and remainder is 12, and hexa value is C. So see here what is the value of quotient value is 4 divided by 16, 0 and 4. So here 4, what is the 12 value? C, and another value is like this. So 1228 we are dividing with 16. So what is the value? 76. Quotient is 12, and here 76 remainder 4, 12, 16 into 4, 64 base 12, and 16 zeros are 4, bottom to top. 4, 12 means what is the 12 value? Already we know that after the 9, 10 equal to A, 11 equal to B, 12 equal to C. So 12 means C, here also C. 4cc base 16. So what is the final answer? 1228 decimal to hexadecimal value is 4cc base 16. Okay. So these are the decimal to any Radix conversion. So how many possibilities are there? Conversion means we are taking today 3 possibilities, that is from decimal to octal, decimal to binary, and decimal to hexadecimal. 3 possibilities are there, and after then we have to discussing. So binary to decimal value from, suppose I am taking this is a decimal value, converting from binary means in the form of 1010 example we have to take in the form of binary only. So decimal to octal means what is the range? It is from 0 to range. Suppose I have to take from hexadecimal means what is the range? 0 to f only. So we have to keep the values in this range only. Binary means 1011 like this, and converting from decimal to octal means we have to range 0 to 7. Why? Because a octal value range is 0 to 7 and hexa values is 0 to f value. So you should take in this range only. So decimal to binary conversion, what are the steps are there? Means first step 1, in the input side what is the radix you can check, at the output side what is the radix we can check. So suppose input base 10, then that is called a decimal is there. So we have to convert to the what is the output radix. So I want to 8 16 like this. What is your requirement? So input base and output base value you have to check, and we are dividing with output base value with input decimal value, output base value with input decimal value. We have to divide with that one, and what is the result? Remainder we will get. So what are the techniques? Divide the base with keep track of the remainder, and remaining bit 0 is the LSB bit and bit 1 is the MSB. If it is a last bit, what is the last bit? That is I am taking as a MSB, most significant bit. So what is the rules to convert from decimal to binary? Means we have to take the decimal number, we are dividing with 2 only, and the decimal values are 0 to 9 range, and the given decimal is odd, then the output remainder is 1. If the decimal value is even number, then the remainder is 0. So what are the values I am getting? The top the right side bit I am taking as a LSB, and leftmost bit is a MSB. So we are taking one conversion example, 125 base 10 to 125 base 10 to binary. So 125 I am taking with binary. Binary means we are in the binary value we are dividing with decimal value. So 125 with decimal binary value is 2. It is a radix or base value. So this radix or base value is dividing with decimal value. So 125 dividing with like this. So what is the answer I get? Means bottom to top, MSB to LSB. So LSB and MSB. So bottom value I am taking as a MSB, top value we are taking as a LSB. So decimal to octal, what is the decimal number and how we are converting to the octal. So what is the first one? Means at the left value we have to take in the form of decimal, that is in the range of 0 to 9, and what is the octal? Means the output value we should take the range of 0 to 7, that is the important, and we have to divide in with decimal value with radix value. So here 1 2 3 4 base 10 convert to octal. So 1 2 3 4 is the decimal value. I am dividing with what is the radix value? I am dividing with this one, 1 2 3 4 dividing with 8. So what are the remainder values? We have to take remainder values and we have to leave quotient, but up to 0 the quotient will be get, the quotient value is 0, then only you can stop the process. So here quotient value is 0, then I stopped that. What is the remainder? 2. So 2 3 double 2. Bottom to top I am taking. Here also convert 1792 to octal. So we are 1792 dividing with 8. So what is the remainder values we have to take, and the quotient values up to 0 we have to do performance, and the remainder values are bottom to top. We have bottom to top, and bottom value is MSB and the top value is your LSB. So convert 127 base 10 to octal, 127 base 8. So we are taking 177 we got. So definitely we have to, what is the output value? We should mention with radix. Input also mention with radix, output also we should mention the radix. So decimal to hexadecimal conversion. So what is the rule? Means we have to take the values from 0 to f. In this range only we should mention. So these are the hexadecimal values from 0 to 15. Binary values I am taking 0 to 9, and after then 9 it will be repeating. So it is the steps to get the decimal to hexadecimal and it is the table of dividing hexadecimal and decimal. So here converting 1228 decimal to hexadecimal. So 1228 dividing with 16 quotient and remainder. So 76 is the quotient, again 76 to dividing with 16, quotient is 4 and remainder is 12, and 4 with 16, 0 is the quotient, then remainder is 4. So when the quotient is 0, then I stopped the process, then I am taking the values from bottom to top. It is the MSB and it is the LSB. So 4, 12, 12. So 12 means C in the hexadecimal language. So 4CC. 4CC. So 1228 base 10. The output is the 4CC. Hexa. It is a radix we should mention. Radix or base we should mention at the output. Okay, it is about the decimal to any radix process. In the next session we will discuss radix to decimal conversion. Any radix to decimal conversion we will discuss in the next session. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.